So welcome to session 4, which is the value of marine artificial structures for decommissioning. And we have an eclectic mix of talks with Stephen Watson from PML, and Molly James from PML, and Anthony Knights, now of University College Cork. So he's just moved there. And so we'll start this session. And the first speaker is Dr. Steve Watson. Thank you, Steve.
Thanks, Dave. Hi, everyone. I'm Dr. Steve Watson. I'm a senior ecosystem service scientist at PML. My talk follows on very nicely from Anel's talk in the last session, where I'm going to be talking about the DREAMS project, and specifically how we translated all that really nice meta-evidence synthesis data into ecosystem service terms. And I'd just like to acknowledge this was a product of all of the DREAMS team, not just myself. But why are we bothering to look at ecosystem services? A lot of the talks and the conferences today have really looked at this box here, box 1 on my right, where we've been looking at how the pressures of artificial structures affect trophic connections and ecosystem functioning. Part of the DREAMS project, we really want to go to that final step, how we begin to link ecosystem functions and the effects on them to society in terms of the many and varied benefits and services that we get from the marine environment. So this will be useful in part because it helps us to answer some of the big policy questions out there, such as how we take a natural capital approach to assessing the marine environment, how we can begin to move beyond biodiversity net gain towards a more environmental net gain focused assessment of how structures impact biodiversity and the services. We talked a little bit about carbon today, but we need to go to that full end around how much blue carbon is actually being stored and sequestered in the sediments if we want to look at things like net zero properly. And lastly, thinking about that this is not an isolated system, there is human users out there, and that by going that final step to look at some of the cultural services as well, we can begin to make trade-offs in how we co-locate human and environmental uses in the sea space. So as Anel kind of pointed out, when we went through all the metadata, we quickly found out that there wasn't a massive amount of decommissioning data available to do this kind of linkage to ecosystem services. So we broke the question down in 2 parts. We firstly asked specifically around what are the ecosystem service effects in terms of impacts from offshore wind farms, and we looked at that from an operational and construction perspective because there just wasn't any data on decommissioning. And then more in line with the DREAMS project, we then went back and said, okay, what data do we have on decommissioning, mostly in relation to oil and gas, tidal wave devices, and also some artificial reefs, and we translated the available information we had into decommissioning terms. And just to say, we also added a lot of data from a parallel project which I was working on at the time. We've been building up at PML over 10 years now, a whole wealth of ecosystem service data linked to offshore wind farms. So what we actually did at the start in relation to the first question is we went back and added all this extra data into the offshore wind component of the database. And that's just a schematic about how we went around that. But in a sense, we ended up with around 132 publications around the offshore wind component of the database. So a brief kind of methodology around how we did this translation from ecological effects to ecosystem service effects. We used SIME, the Common International Classification of Ecosystem Services, which is a framework used in the UK and throughout Europe, and it's just a standardized way about how we can translate from systematic evidence onto broad categories in terms of ecosystem services. The wheel over right at the end just gives you an outline that there's 20 plus different ecosystem services and benefits we can get from the marine environment, and we could use this classification to translate some of the outcomes in the systematic map into ecosystem service terms in terms of regulating, provisioning, cultural services, and we could break that all the way down to carbon sequestration, nutrient sequestration, spiritual and cultural values, etc. And we eventually came out with around 17 to 20 different ecosystem services which can be impacted by offshore wind farms. This was a global study, so we published this now. This was the map of the studies. You can see on land shows the number of studies, and the hashed areas out at sea show the potential expansion of new offshore wind farms. And you can see there's a bit of a dichotomy around, there's lots of evidence around Europe, the UK, America, but there's massive expansion plans, maybe more in the southern hemisphere, so that was one key thing that we pulled out. At the time, we didn't actually find any decommissioning studies. There has some come through now, but at the time we didn't find any. Similarly, there wasn't any data on floating wind, so that's something that we recognised was an evidence gap. Only around 5% of studies actually looked at cumulative pressures, which is something that increasingly funding calls are looking at, so that was a real evidence gap as well. And of course, a lot of it was done in kind of temperate hemisphere studies, including, and there was a lot of studies actually done around Asia as well, but mostly temperate kind of areas. So this is a kind of evidence summary, I guess. Once we'd done all that translation into ecosystem service effects, we quickly realized that, again, lots of data gaps. All the gray shows unknown relationships in terms of the construction and operational impacts of offshore wind farms on the various different ecosystem services. As Anel kind of alluded to, certain ones, ecosystem services were positively impacted. These were mainly in the regulating services or the cultural ecosystem services, but there was very little in terms of regulating services or knowledge around regulating services around the construction phase, which has global importance around things like carbon sequestration, nutrient sequestration, how these things could be impacted by offshore wind farms. And there was potential positive opportunities, I guess, around effects from fisheries, recreation opportunities, and also social acceptance. We found throughout the global literature, people were generally quite positive around how they perceived the potential impacts around offshore wind farms. So we developed this database, we've published it now, but we also had a thought around how can we do something a bit more useful than this. We've done a literature review, a systematic map, but the next kind of thing we were being asked for is can we produce this in a decision support tool kind of format. So we've come up with ORIS, the Offshore Renewable Impacts and Ecosystem Services tool, which we've just published a new shiny website, so please do go check it out. It has 2 access points. You can interrogate the database, which I've just outlined, through an rShiny tool app, which I'll show you in a second. Or if you're interested in specific locations or wind farms, you can also use a GIS portal to go in and see what data is available at individual offshore wind farm locations. So this is just a snapshot of how the rShiny tool, what it looks like. There's various filters, just like you get in a kind of Excel file. And you can go through and filter down if you're interested in primary or grey literature, if you're interested in the operational phase of an offshore wind farm, for example, and you can subdivide that down in terms of different species groups, taxa, et cetera, et cetera. And you can also filter it in terms of ecosystem services, which is probably the novel part of the tool. This is the spatial tool. We worked with PML applications, the visualization team, to develop this part of the tool. And we currently only have it developed for the UK, but we have got some funding. We're hoping to expand the GIS part of it to a global kind of map where you can look up and add potentially data to it as well. It operates in a similar format to the rShiny tool, but we're hoping it's useful. And we've done some showcase events with the Crown Estate Marine Management Organisation who are potentially thinking about using it in some capacity. So that's it really for the first question. Moving on to the second question from the DREAMS project, where's the scientific evidence for decommissioning? We pulled out the 60 studies. I think we managed to find another 3 in L when we were doing this analysis. But it's mainly focused this time around oil and gas, shipwrecks, artificial reefs, and there was 1 around tidal wave devices. And we structured these in terms of the different ways you can decommission. I think this audience is fairly familiar with the different ways, but just in terms of how we broke it down, we looked at complete removal, we looked at partial removal, adding protective structures, we looked at leave or abandoning structures in terms of reefing, toppling, reefing it elsewhere, and also topping, so taking the top off, leaving the bottom part. And this diagram's from a paper which Tony Knights is going to talk about a bit later, but we didn't actually have any studies for the bottom ways of decommissioning, so abandoning elsewhere or repurpose elsewhere, but they are viable options. So this is unpublished data. This is very much a first stab at looking at what the ecosystem service effects of decommissioning are, trying to answer that question, is full removal the best option? And from a quick pass at the first data, you can see by the red, there was a substantially degraded effect on several ecosystem services, as shown by the top table, if you were to fully remove the structure from the marine environment. The red is severely degraded or substantially degraded, and the dark green is substantially enhanced, just for context. But generally, remove parts and add place was quite positive, but as you can see by the white, we still have large data gaps in terms of our understanding of ecosystem services and decommissioning. The second table actually refers to supporting services. So the top table is if it was a supporting service, regulating service, or cultural service, but the bottom table actually refers only to if it was linked to a supporting service, which, if the paper referenced that it was a supporting service, but it could also impact on a final service, such as genetic materials, carbon, etc., we did this as a separate kind of table. So just looking at that, the evidence was mainly negative again for full removal, but this is something that we're currently looking at. So just to summarise, DREAMS project has started to disentangle the effects of decommissioning, largely in a qualitative sense, positive, negative, and this is kind of comparable with current environmental impact assessments, etc. This is how decisions are often made at this kind of level, but we do appreciate that more quantitative methods are probably needed as well. Substantial gaps in our understanding, and this really precludes development of robust policies, particularly around net gain. If we want to start thinking moving beyond biodiversity net gain, we really need to make some of these linkages using more quantitative methods. Lots of potential opportunities for co-location, and really understudied in terms of blue carbon assessments, and that kind of was linked up from Natalie's talk earlier about how we really need to do some more on-the-ground carbon studies around this area. Overall, the ecosystem service work currently pointed to that abandonment could be considered as a more supportive than total removal from an ecosystem service perspective, although remove part and add protective structures was also looking pretty good in terms of being potentially favourable, and this is obviously could be added evidence towards OSPAR kind of strategic targets, etc. But we obviously need more quantitative evidence, and Molly's going to talk a little bit more about that. And we also need the expert opinion as well. It's not just about evidence synthesis, it's about what the policymakers, etc., actually want to do. So Anthony's going to talk more about that from the synthesis perspective. So that's it from me. We've published a lot of this now, particularly around the offshore wind farm work. I also did a webinar around going more into detail around the environmental net gain and restoration angle as part of one of the Insight webinar series. And if anyone's particularly interested around how we added the grey literature to the evidence database, we have also published on that. But thank you.